Hello and welcome back to another tremendous episode of 2 minus 3 equals negative fun. For today's episode, we are talking about angles and how to classify angles. All right, so let's talk about some key terms. We have angle and vertex. An angle is the space or the figure formed when two rays have a common endpoint or a vertex. So I'm going to sketch two rays. So with the magic of Hollywood, I'm going to show us two rays here. So there are your two rays, and they share a common endpoint or a vertex. And they share a common vertex, and that's this green dot that you see here. So their endpoint is called a vertex. And this space in between here is the angle. So all of this stuff that you see in here, that's the angle. So an angle is formed, it's the space created by two rays. All right, let's look at some types of angles. A right angle, and we've discussed this one before in class. A right angle is an angle that measures exactly 90 degrees. So I'm going to attempt to sketch a right angle here. If you had a vertical line, and that's not a bad vertical line, and then a nice horizontal line, not bad. Gotta say, for myself, that's not too bad. And it's marked with this little block in the corner, and that tells you that it is 90 degrees. So a right angle measures exactly 90 degrees. And a acute angle, ooh, that's cute, you might say, is an angle that's little. It is less than 90, but it's greater than 0. So it's like little tiny puppies, little kittens. Those are cute. An acute angle is kind of a smaller angle. It's cute. Yeah. An obtuse angle. You guys have had some fun with this one in class. So this would be an obtuse angle because it is greater than 90, but less than 180. Yeah, so it's a big angle. It's kind of a wider angle. And then you have yourself a straight angle, which is kind of just a straight line, really. We're going to do our best to draw this. So this line here would be an example of a straight angle. It is just an angle that measures 180 degrees. So if we were to measure this one, it's exactly 180 degrees. So you have a right angle that is 90 degrees. You've got an acute angle. That's the cutie little pie there, and that's less than 90 but greater than 0. Obtuse, bigger than 90 but less than 180. And then a straight angle, which is exactly 180. All right, here we see a picture of one of my most favorite cities. That's Chicago. And that big shiny bean there is called Cloud Gate, or the Bean. If you've ever been to Chicago, I'm sure you've seen it. And this gorgeous building here is in the movie Adventures in Babysitting. You're far too young to know that movie. But we are going to use this picture to help us identify and classify right angles, acute angles, obtuse angles, and straight angles. All right, so here we go. So looking at this picture, if we wanted to find a right angle, remember a right angle is exactly 90 degrees. So a right angle is going to be anything in this picture that makes 90 degrees. And I'm just going to kind of sketch it out here. So if we went down this section of the building here, you have this whole front edge here. And all of those windows that you see that go along with it, those would all form 90 degree angles. So those are all right angles. All of these. So anywhere that you see that form, that would be a right angle. So now let's see if we can find acute angles. Well, those aren't too hard to find. So let's look and see what we notice here. So if we look at the top of the roof, you can see we've got this nice kind of a diamond shape for the top. And then you have these rows of windows. Well, you'll notice those form acute angles all the way down. So all of this space in here, those would be acute angles, because those would be less than 90 degrees, but greater than 0. And there are other examples of acute angles, like if you looked at the very top of the roof, you'll see that's an acute angle. I mean, they just go on and on and on. You can see them all over the place. Those are all acute angles. All right, now let's look for obtuse angles. And those are a little bit harder to find, I think. I mean, for me at least they are. But using this roof again, I'm going to use it to help me. So if we look at this edge of the roof this time, oh, that's exciting. Look at this. So this edge of the roof here, and then I'm going to bring in this window line, and you'll see that makes that nice broad angle there. It's like a real wide angle. It's not quite a straight angle, but it's certainly bigger than 90 degrees. That would be an example of an obtuse angle. That's an obtuse angle. And finally, we come across the soon-to-be infamous straight angle, and those are all over the place. I mean, really, if you look, like this window line here, those are straight angles. Yeah, they are. And then, like right above it, some more windows, straight angles. And I mean, I don't want to get you too excited with some foreshadowing here, but those actually form parallel lines. Now, we'll talk about that later. If you can stand the excitement, this is a classic cliffhanger. But we're going to leave it right there with straight angles. And this example here, this would be a straight angle because it's exactly 180 degrees. So a right angle is 90 degrees. Acute is going to be less than 90 degrees, but greater than 0 degrees. An obtuse angle is greater than 90 and less than 180. And a straight angle is exactly 180 degrees. All right, in that last video section, we looked at right angles, acute angles, obtuse, and straight angles in design, like out in the real world. For this, if we were to measure them using a protractor, you can see I've got a protractor projected up onto the screen here, and I've got a red ray, a blue, purple, green, and black ray. And we're going to use these to identify right angles, acute angles, obtuse angles, and straight angles. So a right angle would be, if we went angle MAB, and we name that according to where the angle starts and where it's formed. So we went from MAB. You wouldn't say AMB because that's a different angle. And there are other right angles. You would have another right angle might be, let's see. Yeah, I think I just heard you say it. I think you beat me to it. BAY would be another right angle. All right, an acute angle, and there are several of them. An acute angle, anything less than 90. So one of them, I'm not going to name all of them, but one of them could be, let's see, BAT is an acute angle. Because this space in here, all of this space, is less than 90 degrees. Let's see, and then we have, let's see, just for fun, let's go with another acute angle. This space in here, all of this is less than 90, and that would be angle, let's see, DAY. That's an acute angle. Now if we wanted to name an obtuse angle. So an obtuse angle is anything greater than 90, less than 180. So, and it might not upset you too much, but you might get mad. Sorry, that's angle humor. MAD, that angle is 120 degrees. And I know this because if we were to measure all of this angle measurement here, all of that space is 120 degrees. And I know that because it starts at 0 and it goes all the way up here to 120. So angle MAD, don't be upset, it's just an obtuse angle. And there are other obtuse angles on here. We could keep going if we wanted to. Let's see, what about TAY? So angle TAY, that is an obtuse angle because it's greater than 90 degrees but less than 180. And then before you ask, yes, you may list the straight angle, and the straight angle that is exactly 180 degrees is angle MAY. So yes, you may talk about that. So that's using a protractor to actually measure the angles if you wanted to.